Welcome to another coding tutorial, and in today's video we're going to be making this rainbow pendulum waves. I hope that you're enjoying my series on sound so far. There are still a few more that I want to experiment with. Specifically in this video, we'll be recreating a piece called the Rainbow Pendulum Wave by this YouTube channel called Project JDM, which I recommend you checking it out if you like this series so far. I'll be making tweaks here and there to inject a little bit more of my own personal flavor. Let's start by creating just one rainbow. We're going to do that using an arc function. First, I'm going to actually use a translate function to translate the origin from the top left corner to the middle of the canvas. So width divided by 2 and height divided by 2. Then I'm going to use an arc function to create a rainbow. And now we can just provide the x and y coordinates of the center of the circle as 0, 0. The third and the fourth arguments are going to be the width and the height, or the diameter, which I'm going to put in as r times 2, r times 2. Don't forget to declare what r is. I'm going to set it at 150. And then the fifth and the sixth are actually the starting angle and the ending angle of that arc, which I'm going to put in as degrees. So I'm going to change the degree modes to degrees first. All right, and let's put in 0, 180. And as you can see here, the angle goes clockwise from this point right here. But what I want to do is that I want to draw from this point to this point. So the top half of the circle. So we can do it two ways. We can put in 180 to 360, or we can do from negative 180 to 0. And how about we put in no fill? Alright, so now that we have an arc that's shaped like a rainbow, how about we put in a circle? And this circle is going to be traveling along this path. And to do that, we need to first convert from polar coordinates to Cartesian coordinates to get the x and y position of this circle. To do that, we need to use these two equations. X equals to r times cosine of angle, and y equals to r times sine of angle. And I want the circle to start here, so that is the angle of negative 180, right? And then how about we draw the circle using an ellipse function, and we're going to provide in x and y, and let's make the diameter to be 10 and also fill it with the color white. All right, and then now we want to move the circle along this path, and all we need to do is just incrementing the angle, how about by 1 degree at a time. All right, and then now the circle moves along this path, this circular path, but we actually want it to just bounce us back between this point here where the angle equals to 0 and this point here where the angle equals to negative 180. So how about we write a conditional statement that says if angle is less than negative 180 or angle is greater than 0, then we want to, how about we set another variable called angle v for angle velocity, and we're going to set it to 1. And then that's what we want to do. We want to multiply it by negative 1 every time it hits these 2 points. And then now the circle bounces back and forth. Perfect. Next, how about we put all of this inside a class? Let's go to this arrow here, click the plus sign, and then click create file. I'm going to call this file, how about rainbow.js, and then go to index.html. We want to integrate this JavaScript file. We can do that by copy and paste this line of code here. Change the name to the name of your JavaScript file. So for my case, it's rainbow.js. And this is how you integrate a new JavaScript file into the program. All right. We're going to call this class rainbow. And then inside the constructor function, what we're going to put in here are going to be these set of variables here, right? So radius, angle, and angle velocity. All right. And we can keep angle and angle velocity initialized at these angles and this value here. But for the radius, how about we put in R here so that we can set it as a parameter, because each of our rainbows will have a different radius, right? And then the next method that we want to write, how about display? And this is where we're going to put the set of codes where we drew the arc, right? And then we want to put in this dot for all of this. And I'm also going to put it for X and Y as well. All right, and then the last method is going to be update. And this is where we're going to put in the change in angles here. All right, and then now let's just create one rainbow. Let's call it R, and R is going to be, actually let's call it rainbow, and rainbow is going to be a new rainbow object. And we need to provide the radius R, right? Which we're going to set at 150. And then we're going to call the two methods update and display. Ta-da! All right, so we still have the same thing. Now let's make a bunch of rainbows. So how about we change this to an array, and then I'm going to create a new variable called num. Let's start with 5 rainbows. So we're going to use a for loop that goes from I equals 0 to I less than num, I plus plus, and then we're going to create a set of 5 rainbows. New rainbow, and then for R, instead of setting it at 150 here, we're going to set it based on which rainbow it is, right? So we're going to be using the variable I here. So let's do I. What if we just do I? And then make sure that we call the update and the display methods, right? If we just do I, which goes from 0 to 4, right? We can barely see anything here. So first, we don't want to set I equals to 0. We want I to be at least 1. So let's start by adding 1 here. Then we also want to multiply it by a multiple. How about we set a variable called rmult, and how about I set this to 10. Doesn't seem to change. Oh, we need to put R in here. All right. Now, all of the circles are moving at the same pace, right? Because our angle velocity is set at a constant 1. So let's change that. If we go back to rainbow.js, we want to change this equation here. So the equation for velocity is distance divided by time. And distance for a circle, which is an equation of the perimeter of a circle, is 2 pi r, right? And we have an arc that is half a circle, so that distance is pi times r. So we're going to put in pi, which is 180, times r, which is this dot r. And then we're going to divide by a certain amount of time, which how about we set it as a variable called period. And I'm going to set period as a global variable, which let's put it inside Sketch here. So let period equals to, how about we start at 1,000. All right, it is moving quite fast. How about we set it to 2,000. All right, and I'm going to increase this to 20. All right, so I want you to notice here that this angle V here is relative to what? To the distance r, to the radius r, right? Which means that the bigger the radius, the faster it moves, which is exactly what's happening here. And there are a few things that we need to fix here. The first thing is, actually, let me also make it a little bit slower. So as you can see here, the smaller one moves one period, one cycle, and that's when it all synchronizes back together. But did you see that it doesn't actually synchronize properly? Why is that? So let's look at rainbow.js here. It is because of this conditional statement. So I'm going to actually split it into two conditional statements. One is for this angle here, and the other one is for this. So first, let me print out this dot angle v and also change it back to just one. All right, so it doesn't do anything here, but once it hits negative 180, then it should print the angle. Oh, I wanted to print this dot angle, not this dot angle v. All right, no, this dot angle. So you can see here that it is at a negative 180.72, right? So it moves a little bit further from the point of angle equals to negative 180, which means that when it travels back, it loses a little bit of that travel time. So what we want to do is that it's right here, it lost by how much? By 0.72, right? So we also actually want to set the angle when this conditional statement is true to be such that when it bounces back, it just goes back, it goes right back to where it's supposed to be, which is 0.72 above the point of negative 180. And we can do that using the equation negative 180 minus this dot angle plus 180. And then we can print this out as well. And I'm actually going to put it before the angle is set here. So how about we put it here? And I'm going to also set the initial angle v to be negative. All right, so as you can see here, it starts out beyond negative 80 degrees by 72, right? And so the angle that is set right afterwards is 0.72 above negative 180, which is negative 179.28. And we can do the exact same thing for this side here. So if we print this dot angle, and then print. So you can see here that it is 0.72 above angle 0, right? And on this side, all we need to do is that we need to set this dot angle to be equals to negative this dot angle. And then let's go back to change num back to 5, and then let's see that everything got fixed or not. And there you go. See, everything synchronizes perfectly now. So what we want to do next is that, as you can see here, the smallest arc moves at the slowest pace. But that is actually the opposite of what we want. We want the biggest arc to move at the slowest pace. So what we need to do actually is, instead of setting the angle v relative to the radius here, how about we set another variable called num, another parameter called num, and then we want to replace this dot r with this dot num. And this dot num will go from what? It will go from I equals to 0 to I less than num, right? Which I'm going to put in I in here. But then now we need to change the radius. So we want the biggest arc to travel at the slowest pace. That means that we want where I equals to 0 to have the largest radius. So what we can do is, instead of doing I plus 1, we can just do num minus I. And then num will go from So radius will go from what? Not including this R amount, it will go from 5, 4, 3, 2, 1, right? It's from large to small. So let's try that. So it's not working properly. First, the period is too slow. So how about we set it to 100? So as you can see, the bigger the radius, the slower the pace, right? But the largest one now no longer moves. And that is because we put this dot num here, and num, the initial one, equals to 0, right? So we want to also add 1 here. And rainbow is not defined. Oh, all right, so now everything moves. And as you can see here, when the biggest one completes a cycle, that's when it synchronizes, right? But I want to show you another thing which is we can set, how about we call it frequency of 0. And if I set it to 1, and then I'm going to put in I plus frequency of 0 here. And with this, it's going to be the same thing that we're doing here. So instead of adding 1 here, right? Everything should still be the same. When the biggest one completes one cycle, that's when it synchronizes. But now what we can do is we can change this number. Let's say we do 3, which means that the biggest one completes 3 cycles. That's when it's moving really fast. That's when it synchronizes. So 1, 2, 3. All right, so you can adjust it accordingly, right? And then now another thing that we can do is we can change the variable radius here to have an initial radius of the smallest one. So let's call it R0. And how about we set, let's say we set R0 to be equals to 100. And then now the smallest one has a radius of 100. So you can change around these variables to be based on your likings. All right, so what I'm gonna set is I'm actually going to set R0 to be 30, and then R amount to be 10, and I actually want to set num to be 29, which will make sense a little bit later on. Let's try it. Oh, it's way too fast. And also the period, I want it to be 500. No, let's do 1,000. All right, maybe 2,000. Okay, that's better. And then I also want to actually set the canvas size to be 700 by 400. And I want to actually move everything down by this much. Okay. All right, so before we move to the sound part, let's make it a different color. First, I'm going to change the color mode to HSB. And HSB stands for hue, saturation, and brightness. And hue is a set of color on a color wheel that ranges from 0 to 360, where 0 and 360 is the color red. S is saturation, which is the intensity of that specific color, and brightness is how bright the color is, ranging from 0 to 100. Saturation also ranges from 0 to 100. How about we go to rainbow.js and we provide a third parameter h, and then I'm going to set this .h to be equals to h, and I want to set saturation and brightness to be at the peak of 100. And then inside here, I'm going to set the stroke color to be this .h, this .s, and this .b. And same thing for the color of the circles, which I'm going to set as these same variables here. And then we want to also set what h is going to be. So how about we do 360 divided by num? So we divide 360 evenly, right? And then multiply it by I. And then now we should get a rainbow color. Oops, we don't. And that is because Oh, B has to be... All right, so now we have a rainbow that ranges from red to red, right? Okay, but first, let's change the background color, which I want it to be at 240, 150, and 30. All right, so we have this nice darker blue. And then next, what I want to do is, instead of having a whole range from red to red, I actually want to start it at something that is slightly blue. And then I actually only just want to divide the range between 200 to 300 evenly, right? And then now we will get a color that is ranging between this blue to this pink. Okay, so the next thing I want to do is that I want the balls, these circles, to change color to white whenever it hits the angle 0 and negative 180. And what I can do is that I can actually just set the saturation value to 0, and that is going to make the color white. And we can do that wire, and we can do that here. This dot S to be 0, right? When it hits these 2 points. And then if we do this, I want the stroke to be always the color of the rainbow. So let's set it at a constant 100, but we want to change the color of the balls. So, and it's always white because it starts to hit this left part first. So what we want to do is, how about we write else statement that says, if it doesn't hit, then we're going to increment S by 1. So as you can see here, it turns white when it hits 0 or negative 180, and then it slowly goes back to the rainbow color. How about we also make this to be no stroke, and I also want to give a stroke weight to be a little bit thicker at 1.5. All right. That looks pretty neat. What do you think? And then now we're ready to add some sound. So in my other tutorials, I've shown you a few different ways that we can incorporate sound into the sketch, including how to upload and play MP3 files, as well as how to use the P5 sound library, specifically the P5 oscillator class. In this tutorial, we'll also be using the P5 oscillator class, but I'm also going to show you how to use a different class called the P5 envelope to actually synthesize the sound and make it sound a little bit more like an instrument. So first, let's be familiar with the two key terms. The first one is frequency, and then the second one is amplitude. Frequency is the pitch, while amplitude is the volume. So the pitch is how high or how low the note is. For example, the note A has a frequency of 440 hertz. So each note that we want to play has its own frequency. And if you look at this page here, you can see that the different notes has different frequencies, right? But it also has this thing called a MIDI note, which is a number that is assigned to a specific note. For example, this middle C here has a frequency of 261.625, but has a MIDI note of 60, while this other C, which is C in the middle of the treble clef, has a higher frequency at 523.25 and a MIDI note of 72. So as you can see here, this one has this sound, while this one has a higher pitch at a higher frequency and a higher MIDI note. So how we're going to get these notes is by actually providing these MIDI notes number, and then we're going to use a method called MIDI to freq to convert from the MIDI note to a specific frequency. All right, so let's start with that. So first we want to declare a variable. Let's call it OSC, and OSC is going to be a new object within the P5 oscillator class. And then we want to call the method start to start this oscillator. Then we want to set the frequency. And as I mentioned before, we're going to use a function called MIDI to freq. And we're going to provide a number, let's say 60, which is the middle C, right? MIDI note, and it's going to turn it into the specific frequency. And if I click run, we already hear the sound of the middle C. If I do 72, it's a higher C, right? But we can also set the amplitude or the volume. So how about we put in the method amp, and if we set it to 0, we don't hear anything. And if we set it to 1, we hear it at full blast. So the range of the amplitude is between 0 and 1. And what we can do is, how about we set it to 0, and then if I set a conditional statement that say if mouse is pressed, if this is true, then I want to set the amplitude to 1. Else, I want to set the amplitude to 0. I press, I unpress, and then I press, and then I unpress, then you can hear it. But you can hear that clicking noise, right? And that is because the amplitude goes to this volume at a very fast pace. And that's why you hear the clicking sound. What we can do is that we can provide a second argument, which is how long it would take to ramp up to this amplitude. Let's say that we put in 0.01 for both. You can hear it slightly because this is still a short amount of time. If we do 0.1, you no longer hear the clicking noise, right? But you can see or hear the delay at which when I press the mouse, you can hear that it doesn't go up to that amplitude right away, and it doesn't get released right away. So this is going to be based on how you want to do it. So if you have seen my other tutorials on this oscillator class, you're familiar with this, but now I want to introduce you to this other class called envelope. So let's look at the reference page. The P5 envelope class. Envelopes are predefined amplitude distribution over time. Typically, envelopes are used to control the output volume of an object, a series of fates referred to as attack, decay, sustain, and release, ADSR. And we're going to be using a total of 3 methods inside this class. So let's look at this. Use set range to change the attack and release level. So these are actually the volume at the start and at the end, attack and release. So similar to the oscillator class, these are the volume at the beginning and at the end of each of the sound. And then use set ADSR to change attack time, decay time, sustain percentage, and release time. So we're going to be using these two, and we'll go into the details. And then at the end, we'll be using the method called play to play the entire envelope. All right, so how about we start with set range. So set range, we're basically setting the attack level and the release level, right? So we want to set the maximum and the minimum range of amplitude or the volume. And then after that, we want to go into set ADSR. So as you can see here, it has 4 different variables: attack time, decay time, sustain percentage, and release time. So the attack time and the release time, basically similar to the OSC class, is how long it takes for us to get to the attack level and how long it takes for us to release or goes to the volume that we want at the end. So for us, the attack level and the release level was 1 and 0, and the attack time and the release time was 0.1, right? And then now there are these 2 additional variables. The first one is decay time. So we can set a third volume. That third volume actually is called sustain, also between 0 and 1. So we can set it at a specific number. And here they set it at 0.2. And then decay time is how long it takes for us to get to this sustain level. All right, so as you can see here, there are 3 separate volumes: attack, release, and sustain. And then there are 3 different set of times, right? We have the attack time, release time, and decay time. So how about we first declare a variable called env for envelope, and env is going to be a new p5.envelope class. And then we want to first set ADSR. And I'm going to actually define attack as, let's just do 1 and 0 here. So 1, and release will be, actually I'm going to also put it as volume. So attack and release volume 1 and 0. And then how about we set the sustain volume also at 1. I didn't want it to have 3 different volumes. And then now we just want to set the time, right? So attack time, let's do at 0.01. Release time, I want it to be at 0.1. And then I want the sustain time to be at 0.01. And then now what we need is we can just put in this other method, which is set range, right? Set range is going to be between attack volume and release volume. And then for set ADSR, it will be attack time, right? And then sustain time, sustain volume, and then release time. So a lot of different variables here, but it makes sense. Okay, so now we have this envelope here, which sets the volume. And then now instead of putting in 0 here, we just put in env. And instead of playing the amplitude here, we just do env.play. And we don't need this anymore. And then now we have a sound that is a little bit more instrument-like, and you can change these 6 variables to get the sound that you like. All right, so this is exactly what we're gonna do inside our sketch, and we're gonna put it inside the constructor function. There you go. And then make sure you put in this dot for the variable env and also OSC. And instead of this 72 here, I'm going to create another variable called this.note. Actually, it is going to be a parameter here. And then inside the update function, we want to also play this envelope. All right, and that's it. Now we need to go back to sketch.js and we need to, first, how about we set an array called MIDI notes. And the reason that I'm actually having 29 rainbows is because I want to create 4 octaves of note, 4 octaves of just the white key on the piano from C to C, but I want to include the last C. So it has, each octave has 7 notes, so 7 times 4 plus 1, and that is 29. And these set of MIDI notes are going to be this. And then in here, I'm going to set note to be equals to MIDI notes of I, and then we just put it in as an argument here. And I think that should be it. Let's try. Ooh. And env is not defined. Env, this.env, this, oh, here, this.env. I think that's it. Nice. All right, I actually want it to move a little bit faster, and essentially what we can do is we can increase this frequency here from right now set at 3. How about we set at 30? That might be too much. Let's do 10. So by setting freq 0 equals to 10, it means that the largest one has to complete 10 cycles before all of these rainbows will synchronize, right? but this way it allows it to actually move at a more similar pace, all of these rainbows. So there you go. This is my own version of the pendulum waves based on the project by Project JDM. So I hope that you enjoyed this one and give it a try.